ഹലോ ഫ്രണ്ട്സ്, കേരള PSCയുടെ ട്രേഡ്സ്മാൻ-ഇലക്ട്രോണിക്സിൻ്റെ നവംബർ 3, 2016 നടന്ന കാറ്റഗറി നമ്പർ 527/2015 പ്രീവിയസ് ക്വസ്റ്റ്യൻസ് ആൻഡ് ഡീറ്റെയിൽ സൊല്യൂഷനാണ് ഈ വീഡിയോയിൽ. ഫസ്റ്റ് പാർട്ടാണിത്. ക്വസ്റ്റ്യൻ നമ്പർ 1. The ripple factor of a half wave rectifier is, answer is option D, 1.21. The detailed answer. What is a ripple factor? The direct current delivered by a half wave rectifier is certainly not a pure direct current, but a pulsating direct current. Pulsating means to move in a rhythmic manner. There are still some alternating current components left over while converting the AC signal to a DC signal. This undesirable leftover AC component contained in the output side of the rectifier is termed as ripple. These ripples in the output direct current signal can be minimized by utilizing filters. The example of filters is capacitors and inductors. Filters. For the development of a decent rectifier, the ripple factor ought to be kept as least as possible. Ripple factor actually provides the quantity or number of ripples present in the output DC signal. It is further utilized to measure the efficiency of rectifiers. That is, how well this rectifier is converting AC voltage into a DC voltage. Mathematically, the ripple factor is defined as the ratio of the RMS value of an alternating current component in the rectified output voltage to the average value of rectified output. That is, ripple factor equal to RMS value of AC component in the rectifier output divided by average value of rectifier output. The extra important point is that the rectifier and corresponding ripple factor. For half wave rectifier, the ripple factor is 1.21 and for full wave rectifier is 0.482. That is, half wave rectifier containing more ripples than full wave rectifiers. That is, full wave rectifier is a pure form of DC signal when comparing to half wave rectifier output signal. Question number 2. Which of the following is the fastest switching component? Answer is option A, MOSFET. MOSFET is the fastest switching component in electrical engineering due to its high input impedance, low switching time and low power consumption. MOSFET is widely used in electronic circuits such as power amplifier, digital circuits and switching regulators. This is a symbol of MOSFET. What is a MOSFET? The metal oxide semiconductor field effect transistor is a type of field effect transistor most commonly fabricated by the controlled oxidation of silicon. It has an insulated gate, the voltage of which determines the conductivity of the device. This is a structure of MOSFET. It contains the oxide and a channel, and the terminals are source, gate and drain. Primary use is to control conductivity or how much electricity can flow between its source and drain terminals based on the amount of voltage applied to its terminals. Characteristics. MOSFET has 3 terminal device, that is source, gate and drain. It is unipolar, controlled by the voltage, and it has high input impedance. So it is a high input impedance device. Advantage of MOSFET: ability to scale down in size. It is used to work at a greater efficiency but with a lower voltage value. As it has no gate current, so due to this it gives a high input impedance which produces a high switching speed. Disadvantages: it is susceptible to damage due to its thin oxide layer which can get damaged because of electrostatic charges. It gets undesirable when a voltage gets overloaded. Applications of MOSFET: it is used as an inverter, can be used in digital circuits, used as passive element like in an inductor, resistor and capacitor. It is used as a high frequency amplifier, used in brushless DC motor drives, electronic DC relays, and used in switch mode power supplies, used as a switch and amplifying signal in electronic devices. Question number 3. The final power amplifier in a radio transmitter station is usually, answer is option C, Class C amplifier. The Class C amplifier is a form of switching amplifier in which the transistors are on for less than a half cycle, that is less than 180 degree. The usual application for Class C amplifier is an RF transmitter operating at a single fixed carrier frequency. Class C amplifier has higher efficiency and lower distortion. The extra note is there's a comparison of various power amplifiers by efficiency and conduction angle. Just by heart these points. Class A power amplifier efficiency is 25% to 50%. Conduction angle is 360 degree. Class AB efficiency is below 78.5% and conduction angle is between 180 degree to 360 degree depending upon the operating point. Class B push-pull power amplifier efficiency is 78.5%. Conduction angle is 180 degree. Class C between 78.5% and 100%. The conduction angle is less than 180 degree. Question number 4. In AM radio receiver, the oscillator frequency is, answer is option B, incoming signal plus 455 kHz. The most typical AM radio receiver circuit is the super heterodyne receiver. In the receiver circuit, the local oscillator frequency is FLO equal to FRF plus FIF, where FRF is the radio frequency or signal frequency and FIF is the intermediate frequency. Since for AM broadcast, the typical intermediate frequency is 455 kHz. So, local oscillator frequency FLO equal to FRF plus 455 kHz. That is, FLO must be higher than the signal frequency by intermediate frequency, that is 455 kHz. Important parameters of AM and FM. Carrier frequency is 540 to 1700 kHz. For FM, it is 88.1 to 107.9 MHz. Carrier spacing for AM is 10 kHz and for FM it is 200 kHz. Intermediate frequency for AM is 455 kHz and for FM it is 10.7 kHz. Intermediate frequency bandwidth is 6 to 10 kHz in for FM. For AM and for FM it is 200 to 250 kHz. Audio bandwidth for AM is 3 to 5 kHz and for FM it is 15 kHz. By heart these values. Question number 5. The voltage gain of an emitter follower configuration cannot be more than, answer is option A, 1. The voltage gain of an emitter follower is just a little less than 1. Since the emitter follower is constrained at the diode drop of about 0.6 volt above the base. Its function is not voltage gain but current gain or power gain and impedance matching. What is an emitter follower? Emitter follower is a common collector amplifier, is one of the three basic single stage bipolar junction transistor amplifier topologies typically used as a voltage buffer. The emitter follower amplifier presents a high input resistance to signals applied to its base and provides a low resistance effective voltage source at its output. These characters make the emitter follower amplifier well suited for use as a voltage buffer amplifier. The common collector amplifier is also called emitter follower amplifier because the output voltage signal at the emitter is approximately equal to the voltage signal at the input on the base. Configuration and input impedance and output impedance of various configurations. For common collector, the input impedance is high and output impedance is low. For common base, input impedance is low and for output impedance it is high. Common emitter, input impedance is moderate and output impedance is moderate. Question number 6. The doping concentration in Zener diode is, answer is option B, very high. Zener diodes are semiconductor devices that allow current to flow in both directions but specialize in current flowing in reverse. This we can identify from the VI characteristics. Zener diode is also known as breakdown diodes. Zener diode is a PN junction diode used in the breakdown region by applying a voltage in the opposite direction to normal PN junction diodes. Zener diodes are heavily doped so that the depletion region formed will be very thin and electric field at the junction will be very high. Zener diodes are the most common electronic components used as stable voltage references for electronic circuits. Application: it is used as a voltage stabilizer, protects from over voltage, clipping circuits. It protects the electricity meters from over voltage. In communication, it helps transmitting television and FM signal, providing clear and audio and video. The difference between Zener diode and PN junction diode: it allows the current to flow in both directions, which means that its current can flow forward as well as in reverse direction for Zener diode. But for PN junction diode, it allows the current to pass only in one direction, which is a forward direction. Zener diode is highly doping, and for PN junction low doping is only required. A reversed current has no effect on a Zener diode. A reverse current on a PN junction diode damages its junctions. Question number 7. Binary number system uses dash symbols. Answer is option 2. A binary number is a number expressed in the base 2 number system which uses symbols 0 and 1. A hexadecimal is a numbering system with a base 16. It can be used to represent large numbers with fewer digits. In this system, there are 16 symbols or possible digit values from 0 to 9, followed by 6 alphabetic characters A, B, C, D, E, and F. The octal or octet for short is the base 8 positional number system and uses the digit 0 to 7. A decimal number system is a standard system for denoting integers and non-integer numbers. The decimal system consists of 10 single digital numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Question number 8. Trimmer is a variable. Answer is option D, all the above. A trimmer or a preset is a miniature adjustable electrical component. It is meant to be set correctly when installed in some devices and never seen or adjusted by the device's user. Trimmer can be variable resistors, that is potentiometers, variable capacitors or trimmable inductors. Trimmers are used to initially calibrate the equipment after manufacturing, also used to trim the values of your resistance, managing the adjustments, tuning and calibration of the circuitry. Question number 9. The number of turns in secondary of dash transformer is more than the primary. Answer is option B, step up. A step-up transformer is a transformer that has a primary voltage is lower than the secondary voltage. In the step-up transformer, the secondary side voltage and turns are greater than the primary side. Just look what is turns ratio of a transformer. That is turns ratio of a transformer equal to N1 by N2, which is equal to V1 by V2, which is equal to I2 by I1, where N1 is the number of turns across the primary side, N2 is the number of turns across the secondary side, and V1 is the primary side voltage, V2 is the secondary side voltage, and I1 is the primary side current and I2 is the secondary side current. Turns ratio of for a step-up transformer, that is secondary side voltage is greater than the primary side voltage. N equal to N1 by N2. Here N1 is a lesser value and N2 is greater value. Therefore, N is less than 1. What is step-down transformer? In step-down transformer, the primary side voltage and turns are greater than secondary side. Therefore, the turns ratio for a step-down transformer is N greater than 1. That is N1 is greater than N2. Question number 10. In a PN junction diode, the barrier potential offers opposition to. Answer is option B, majority charge carriers in both regions. In forward biasing, the applied voltage of the battery mostly drops across the depletion region and the voltage drop across the P side and N side of the PN junction is negligibly small. It is due to the fact that the resistance of the depletion region is very high as it has no free charge carriers. The barrier potential restricts the flow of majority charge charge carriers. In forward biasing, the forward voltage opposes the potential barrier. As a result of it, the potential barrier height is reduced and the width of the depletion layer decreases. As forward voltage is increased at a particular value, the depletion region becomes very much narrow, such that the large number of majority carriers can cross across the junction. Question number 11. Negative feedback in amplifier dash the stability and decreases the voltage gain. Answer is option A, increases the stability. The feedback amplification factor is given by AF equal to A 0 divided by 1 plus A 0 into beta, where A 0 is the open loop gain and A 0 beta is the loop gain. This is the feedback network. The negative feedback in amplifier causes reduce the gain and increases stability in open loop gain, increases the bandwidth to maintain constant gain bandwidth product, reduces the distortion and noise in the amplifier. The signal to noise ratio is not affected. The voltage gain AV of an amplifier is defined as the ratio of output voltage to the input voltage. AV equal to V0 by Vin. In a negative feedback amplifier, closed loop voltage gain is given AV equal to V0 by Vin, which is equal to 1 divided by 1 plus A0 into beta, where beta is the feedback factor and A0 is the open loop gain of the amplifier. From expression 1, it shows the open loop voltage gain has reduced by introducing negative feedback. When 1 plus A0 beta term increases, AV decreases. Question number 12. The time base of a CRO is dash waveform. Answer is option A, sawtooth. What is a CRO? CRO is a very fast XY plotter that shows the input signal versus another signal or versus time. The application of CRO used to analyze the waveforms, transients, phenomena and other time varying quantities from a very low frequency range to the radio frequency. Time-based generator is one of the block in a CRO that we can understand from this block diagram. What is time-based generator? It generates an output voltage or current waveforms which varies linearly with the time. The signal generated by the time-based circuitry of the CRO is basically a sawtooth waveform. The horizontal velocity of a time-based generator must be constant. The displayed signal should be varied with time. It makes the signal to sweep the beam horizontally across the screen. Then the displayed signal varies linearly with the time. Hence the voltage is called sweep voltage. The time-based generators are called sweep circuits. In CRO, the time-based signal is applied to the X plates in the XY mode operation only. In YT mode of operation, the time-based signal is connected. Time-based generators are used in CRO, televisions, radar displays, precise time measurement system and time modulation, etc. Question number 13. The moving iron meter is usually used for the measurement of. Answer is option A, AC and DC. Whatever the direction of the current in the coil of the instrument, the iron vanes are so magnetized that there is always a force of attraction in the attraction type and repulsion in the repulsion type instruments. Thus, moving iron instruments are unpolarized instruments. That is, they are independent of the direction in which the current passes. Therefore, the instruments can be used on both AC and DC. Power consumption in these instruments are higher for low voltage range. Question number 14. Integrator is a dash filter. Answer is option B, low pass filter. A low pass filter is used in circuit that only allow low frequencies to pass through. This is a circuit of low pass filter. It is often used to block high frequency AC current in a circuit. In other words, low pass filters help in removing short term fluctuations and provide a smoother form of signals. An ideal indicator acts as a low pass filter. V0 of S divided by Vi of S equal to 1 divided by 1 plus SCR, where C is the value of capacitance and R is the value of resistance. V0 of T equal to V0 into e raised to minus T by tau. For the capacitor to act as an integrator, the capacitor should discharge slowly, and this discharging time depends upon the time constant tau. Less the time constant, then faster will be the discharge. More the time constant, then slower will be the discharge. Question number 15. Op-amp may be used as, answer is option D, all of the above, that is summing amplifier, voltage comparator, differentiator. What is an op-amp? An operational amplifier is a DC coupled high gain electronic voltage amplifier with a differential input and is usually a single-ended output. An op-amp produces an output potential that is typically 1 lakh times larger than the potential difference between its input terminals. Op-amp is an integrated circuit that amplifies the difference in voltage between two inputs. It is so named because it was developed for performing arithmetic operation and also can used as amplifier, buffer, comparators, filters, etc. Op-amp IC 741 or LM741 is one of the most used operational amplifier IC that performs both the mathematical operations and amplification functions. What is a summing amplifier? This is a figure showing the summing amplifier. The summing amplifier is also called a voltage adder, is another type of operational amplifier circuit configuration that is used to combine the voltages present on two or more inputs into a single output voltage. Vout equal to minus RF divided by Rn into V1 plus V2 up to Vn. What is voltage comparator? This is a figure showing a voltage comparator. A comparator circuit compares two voltages and output either a 1 or 0 to indicate which is larger. Comparators are often used to check whether an input has reached some predetermined value. Comparator circuit does not use feedback. Here, Vin and Vref are the input to non-inverting and inverting terminals of op-amp. The circuit amplifies the voltage difference between Vin and Vref and output results at a Vout. If Vin is greater than Vref, then the output voltage at a Vout will rise to its positive saturation level, that is the voltage at a positive side. If Vin is lower than Vref, then the output voltage Vout will falls to its negative saturation level, that is the voltage at a negative side. What is differentiator? The differentiator op-amp configuration produces an output voltage that is proportional to the rate of change of the input voltage by measuring the current through a capacitor. The output of differentiated circuit is the first derivative of the input signal. This is the circuit of differentiator. Here the RF forms a negative feedback element across the op-amp. The input signal to the differentiator is applied to the capacitor, which blocks any DC current. So there is no current flow to the amplifier. Summing point X result in zero output voltage. The last question of this video, Part 1, is question number 16. The timer IC 555 is available in dash package. Answer is option C, 8-pin dual inline package. The 555 IC is an integrated circuit used in a variety of timers, delay, pulse generation and oscillator applications. It is one of the most popular timing ICs due to its flexibility and price. This is the 8-pin dual inline package of IC 555. Pin number 1 is ground, 2 is trigger, 3 is out, and 4 is reset, and 5 is control, and 6 is threshold, and 7 is discharge, and 8 is VCC. Consider schematic diagram. There is voltage divider, threshold comparators, and trigger comparators, latch, output, and discharge. What is a voltage divider? Between the positive supply voltage VCC and the ground GND is a voltage divider consisting of three identical resistors of 5 kilo ohm to create reference voltages for the analog comparators. The threshold comparators is the comparator. The negative input is connected to voltage divider's upper reference voltage and the comparator's positive input is connected to the threshold. Trigger comparators. The comparator's positive input is connected to voltage divider's lower reference voltage and the comparator's negative input is connected to trigger. Latch. A set reset latch stores the state of the timer and is controlled by the two comparators. Output. The output of the latch is followed by an output stage with a push-pull output drivers that can supply up to 200 mA for bipolar timers. Discharge. The output of a latch controls a transistor acting as an electronic switch that connects discharge to ground. Thank you.